So I'm the VP of Pre-Sales and Customer Success at Volt Active. And prior to Volt Active, I spent 15 years in the data industry, so in big data, and principally at Cloudera, but also at other startups. And I have a long experience also in streaming, so I worked at a startup in the UK that was running on streaming analytics over social media data with very, very high volumes, so things like the Twitter firehose. So I'm very familiar with the many, many challenges that sit with running streaming systems. And prior to that, I worked in CRM and billing in the telecom sector. So again, another area of high volume, complex data. And what I want to talk to you today about is really, the new worlds of UNS, how Volt works with UNS systems, and then how we can then process and take that data and do something useful with it at the edge. So before I start, I'm going to give you a brief history of some of the challenges of the deployment models that we've had. So in the past, our early systems are often centralized, and that was out of necessity. These would be for reasons such as cost, lack of local expertise, and our business models were often highly, highly centralized. And then we evolved. The advent of the PC era started in the late 80s and got better as we went through the 90s. And that empowered end users. That gave us the ability to do things locally, so we could run applications on desktops, spreadsheets, build local databases, and it was very, very useful, but it came with unique challenges. And certainly the challenges of managing large amounts of infrastructure that are deployed locally are problematic. And IT has then sort of started to evolve itself yet again to moving back to models that are somewhat more centralized. And cloud is kind of the next evolution of IT, right? So what's happened in cloud is it's giving us a lot of that power and flexibility, so end users can make decisions about the types of applications they want to run and build, how they want to run them, where they want to run them, and how often. But that also presents challenges. So it gives us flexibility. That's great, right? But that flexibility has sometimes led to shadow IT, so we've ended up with more and more data, less and less control. But we then have other challenges, like ingress and egress. That's hugely expensive in cloud, right? Particularly egress. It's one of the sort of areas that's not always well talked about. How do I move data out of my cloud, and how much does it cost me? Then we have connectivity dependencies. For many, many parts of the world, that's great, right? We've got strong internet infrastructure that allows us to connect reliably. But if we're deploying at the edge, either it could be a container vessel at sea, it could be a mineral extraction or resource extraction facility that's in a remote location. We don't have reliable internet connectivity. And that, again, presents us some unique challenges. We also become a bit beholden to it. There is a cult of cloud, right? Everyone's like, oh yeah, just spin it up and run it in the cloud, without really necessarily understanding what that means in terms of the complexity and the cost. And then there's this new risk that's been well identified, which is cloud concentration. So cloud concentration is the problem of putting all our eggs in one basket. So if we're running with one particular cloud provider, what happens if that cloud provider is subject to a cyber attack? How does that impact our manufacturing facility? How do we then process that data reliably and consistently, and without losing fidelity or accuracy, or making really important decisions in a timely way? And this was identified by Gartner last year as a top 5 risk. And one of the most important things is, how do we mitigate against some of that risk? So, as I said, these are the failures that do happen, and these are examples of very quickly Google searching of cloud failures. So as I said, it can be a cyber attack. It could be just human error, right? Someone's deployed bad code inside the cloud provider and it brings it down. And that causes a significant impact on your business. So we start to, there is now this movement of both repatriation but also localization. I need to do things near where the data is created. And how do I do that? And then we have to think about, from our IoT data, how do I unify that data and make sense of it and contextualize it? So UNS, this has become one of the most the newest themes in the IoT space. So how do I take data from many, many systems and make sense of them? So I want to I want to receive data from my plant and equipment, and make it immediately available so I understand, oh right, that particular machine has got an issue in this area. And also, how do I integrate it with other data sources? So how do I bring in data from CRM or ERP and combine it with those other data sets to make an even more impactful and more powerful decision? So how do I learn, oh right, I've got a piece of inventory that's running on this particular firmware version and it's now having an error. How do I then take an action on it? And this is where we start to think about how we bring these worlds together. And these are based on standardizations, right? So ISA 95, EC 62264, and these underpin what we're trying to achieve with UNS, which is an aggregated view of our world, and not just the individual machine, but across the enterprise. And this is, as part of what we're doing here at Volt is how do we bring these worlds together, and in partnership with a company called HiveMQ. So the business impacts are real. Data silos, I think for as long as I've been in the industry, have been a problem. Every time I've worked over the last nearly 30 years, we've got a silo here, we've got a silo there, and how do I start to bring that data together? And technology being technology, we solve the silo, and then we go and create a brand new one as we bring in new software and products. And then we have the problems with multiple screens for assets. So we might be looking at many tabs within a browser to get a view of our assets, or we might be in an operations center trying to look at a lot of screens to understand what's going on perhaps with a water pipeline or a data network. And that makes it difficult. As human beings, we're able to correlate data, but we can't always correlate it quickly. And how do we make that correlation faster and more reliable? Our attention span is not always as strong as we would hope. So we want to ensure that we hit, identify those events and act upon those events as quickly as we can. And it's, as the slide says, human timeliness is less than ideal for these machine time reactions. Some of these machines are sending data in milliseconds. Humans react in best case seconds, often in minutes. And by that time, we've had, potentially serious consequences. We've perhaps stalled the plant, manufactured goods that are no good, and we've caused wastage in our systems. And then there's the human side. Human beings are, we are amazing, but we're fallible, and we make errors. And then there's the impact of those errors, right? So those defects cause us to waste materials, waste resources, energy, but also the impacts the people we're actually producing those things for. We're missing our business SLAs, and we don't want to do that. We want to be a reliable partner to our customers. So how do we then pull those Japanese concepts of Mura, Muri, and Muda and make them work for us? So avoid that wastefulness, ensure that we eliminate process unevenness, or avoid stressing critical assets. So in our view, we need a hybrid solution. So centralized infrastructure, and as the previous speaker said, which is perhaps we're going to send data to the cloud and do machine learning on that data in the cloud. That also gives us the ability to do overarching view of that data and governance, to ensure that it's correct and it's monitored and it's secure. But it also allows us to do things like develop and refine business models. So we can build business rules in our cloud infrastructure, but we can also do more advanced work in AI and ML, where we can take all the data that we've gathered from our various plant equipment across many, many geos, and start to build useful rules that allow us to identify early on, that signal tells us there's a potential problem at that site, and proactively start to do something with that data. So not just give us a signal, but actually turn that signal into useful remedial action. And then we want to deploy at the edge, right? So this allows us to solve some of those cloud challenges that I talked about, which is reducing ingress and egress costs. So making sure that we're only sending the data that we care about to the cloud. We don't care about often lots of the good signals. What we care about is the anomalous data. And then also, more importantly, act on the data where and when it's created. So, if we know that we're seeing a problem in a particular location, so perhaps we've got a manufacturing plant in Berlin, and that manufacturing plant is having an issue, how do we perhaps redirect some of the manufacturing need to another plant to ensure we meet our SLAs? But also act quickly. So if there is a machine that's starting to produce bad goods, intervene fast and avoid waste, which is both good for our bottom line, but also good for the environment. And also scale where we need it. Sometimes we don't need lots of infrastructure everywhere, but what we need is infrastructure where it's appropriate. And being at the edge doesn't necessarily mean physical hardware in those locations. It could be point of presence systems. So it allows us to have it in like near edge locations. And then it's, as I said earlier, the problem is also connectivity. If we're talking about vessels at sea, well, we can't guarantee those vessels will be able to reliably connect. So we need to be able to react to data in place. And then finally, it's about compliance. If we're talking about things like medical data, we don't want that going into a remote cloud, especially if that remote cloud is out of our own jurisdiction. We may want to contain that data where it's needed. So if we're talking perhaps medical devices, it stays within a particular country and ensures that it meets local regulation. And this is important from a sovereignty point of view, but also legitimately privacy. So from Vault's point of view, what we're proposing is that we work with HiveMQ as a partner, and they give us that ability to collect data from assets. So they have an MQTT broker which collects data from sensors in equipment, and it's a powerful product. It's highly configurable. It has delivery guarantees, and it's also secure. Again, which is important as we move data around. We want to ensure that it's well protected. And the important thing is that Hive gives us is that ability to support UNS. So it gives us this topic name which allows us to represent an asset hierarchy. So at the very highest level is our business, and then we move down to region, site, specific location, individual asset, and sensor within that particular asset. And what we've done is that we've added extensions to Hive in partnership with them, which pushes that data from Vault, from Hive into Vault. This reduces the latency on that data and allows us to make faster event decisions. And what we do at Vault is that we're a high-performance unified data platform which allows you to receive and process data in real time. But we also have the ability to integrate AI and ML models that are produced and use that to then essentially react to data, but not only react to that data, make a decision, and then use that data to send control message back to HiveMQ. So if we're talking about an individual piece of equipment, we say we may stop that piece of equipment, or we send new configuration parameters to that piece of equipment to change what it's doing, so it ensures that we avoid those issues around waste and so on. But also, the other key piece is reducing the data that's sent to the cloud. So we'll perform a lot of that processing on the edge and avoid the traffic that going to the cloud. So it gives us a lot of useful capabilities that help us run our businesses more efficiently. And here is some of the activities that that are impacted by those standards. So we're thinking about scheduling, how giving us that holistic view of our data, sensing data, actuating and then controlling it. And it's a large, complex set of activities that we need to really ensure that we get a complete picture of and do those effectively. So as you can see, there's a great deal of complexity embedded into that. And what we're trying to do is ensure that we meet our business SLAs and do that effectively with an advanced, modern solution. And here we've got what we've developed as a reference architecture. So on the left side is what we've got is observation systems. So these are the things that are collecting data from sensors. This could be cameras, it could be configured sensors, data on piece of equipment. It could be acoustic data. So what we're doing with these pieces of data is that we will build models off of the data that we collect and use those models as, inside Vault. So Vault will receive these many pieces of data, and then using a model, be able to then inference and act upon that data as it's received. And that inference and acting is to be clear, Vault's designed to work with millions of events per second, and with very low levels of latency. We then take that data, make a decision either based on a business rule or an AI model that we've published to Vault, and then send those control signals back out to the control systems to ensure that we're able to update and manage our infrastructure in a timely and efficient manner. And the key thing is that we're avoiding the risk of human error in these systems and doing these things consistently, reliably, 24 hours a day. The other piece is that we're then taking that data that we've processed but sending it up to a centralized system. And this could be a public cloud, but it also can be a private cloud. So you may have an on-premise OpenShift, and we will run Vault on that infrastructure and take that data and use that to give us a holistic view of all of our infrastructure across many locations. And then from that, we can take that data and combine it with data from ERP and CRM, but also send the data we received down to the data lake. And this is where the closed loop comes in, right? So what we're doing here is refining those models. And one of the problems often with AI and ML is that we'll build a great model, but then when we release that model into the wild, we get model drift. And the model starts to move away from what we've already learned. So what we have to do is take the data and look at the actions we've performed against a particular model version and determine, was that the right action? Did it cause us to solve the problem that we intended? Or was it a miss? So we want to avoid the challenges of false positives, but also make sure we are really hitting our numbers and improving our overall business SLAs with a better, more efficient system. And the idea is to have a continuous feedback loop of taking the model, executing the model, rerunning it and refining it over and over, and it will be a continuous process. And this is where this would be the new work for the operator. The operator is now focused on models and understanding, what's happening across the business and giving us a more informed and accurate view of what's going on, but also making sure we're actually doing what we say we should be doing, which is meeting our business SLAs from a manufacturing point of view. So I have run through this quite quickly. Are there any questions?
Henry Nash from 3 IoT. Very interesting topic.
Yep.
So do you see this unified namespace as being adapted by a lot of enterprises? Is it something that you see proliferating?
Oh, absolutely. I mean, the challenge has always been that we couldn't easily identify individual. We could see data about each component, but not all those components combined, and it made it hard from a namespace, from an identification point of view, to know exactly where a problem's at. We might have an individual sensor, but we couldn't correlate it readily with other pieces of data. So UNS gives us this clearer picture of what's going on a particular, right down from the top level all the way down to the individual sensor. So it might be, if we're talking about a particular plant, maybe there's a weather condition that's affecting the plant. So it allows us to have a little bit more context about what's going on.
But can you see opportunities to kind of pivot from the old siloed architecture of where it's not, you don't have that horizontal sort of model where you're leveraging the OT data against the sensors and the IoT data, moving from that to the unified space namespace? Is that
I think there's an enormous opportunity to, because it makes it easier to manage what we're doing, right? So one of the things is that we're great at creating data as a race, right? As a species, we keep creating more and more data. And if you looked at some of the data points from over the last, the exponential rise of data is a problem. I mean, you're in a mobile network. The data you were running 10 years ago is probably 10 times what it is today, right? And making sense of that is becoming progressively harder. So being able to unify that data helps us make sense of the data. The data is no good on its own, right? It needs to have context. It needs to have this marrying up with other data to bring us intelligence and be able to act on it meaningfully. Data in isolation isn't always that useful. It's when we combine it with other sets of data that we start to make informed actions and decisions.
That's great. Thank you.
No, thank you very much.
Any other questions? Yeah.
So just as a recap, so businesses are always distributed, right? But our businesses weren't well aligned to those models. We often ended up with centralised IT, but we had manufacturing plants sprayed all over the world. And what we want to do is reduce some of that dependency and risk. So making sure we've got overarching governance and with a modern edge architecture. And what we then is, to make those systems manageable, scalable, and complement our central IT. Thank you very much for your time, and I'll see you soon.